In this question, we're given triangle ABC, and we're also given the side lengths of this triangle. We have the line BD, which is the angle bisector at B, so these two orange angles are equal. And we have the line AP, which is perpendicular to the angle bisector. The first thing we're asked to do is to show that M is the midpoint of line AP. Now, if we look around M, we see that we have right angles. In particular, AMB is a right angle, and PMB is also a right angle. So we can see if we look at these two triangles, PMB and AMB, we have one pair of equal angles, these two right angles. We have another pair of equal angles, these two angles at B, so that's PBM and ABM. And we also have a common side length between these two triangles, that's BM. So we have a side length and the two angles around it. These are both in common for the two triangles, so from angle side angle, we know that the triangles AMB and PMB are congruent. Because these two triangles are congruent, this now allows us to deduce that all of the sides in pairs are equal to each other. In particular, if we look at PM, this length is going to be the same as AM. So M is indeed the midpoint of AP, as asked. We're also asked to find the length of PC. Now, we already know the length of BC, that's 160. So if we can find the length of BP, then we can also find the length of PC. Again, using the fact that these two triangles are congruent, the length BP is the same as the length BA. So this length and this length are equal. In particular, BP is 85. That means we can work out PC as follows. PC is going to be BC minus BP, which is 160 minus 85, giving us a length of 75 for PC. In the final part of this question, we now introduce the other angle bisector at C and the corresponding perpendicular to it. The perpendicular and the angle bisector intersect at N, and I've continued the perpendicular so that it intersects BC at the point that I've labeled Q. We're asked to find the length MN. Now, we can play a similar game to before, where we say CNA and CNQ are congruent by angle side angle, because there are two right angles here. These two angles are equal from the bisector, and the length CN is common. So we know, as before, that N is the midpoint of AQ, and we can work out the length BQ in a similar way that we worked out the length PC. So CQ is the same as the length CA, which is 103, so we can subtract that from the 160 to get a length of 57. This finally allows us to work out the length QP, which should be 160 minus 75 minus 57, 28. And the final step is to notice that since M is the midpoint of AP and N is the midpoint of AQ, we can take a scale factor centered at A with factor 1/2, which will take the length PQ onto MN. So because the scale factor is 1/2, when we shrink from the point A, this length PQ, which is 28, will now become the length MN, and it will be 14. And this finishes the problem.